Okay, so we are solving multi-step equations, and I'm going to do the odd problems, and that should help you for the even problems. So we'll see how this goes. Okay, so number 3 is a just basic two-step equation. So if we go over the notes and we go over those rules, what we need to do right now, we have a variable term. This is the variable term because it's a number multiplied by a letter. And then we have our constant. So in general, in these two-step equations, in general, we're getting all the constants to one side, the variables to the other. In this case, we're going to go ahead and move that variable. And the variable is going to come over here. And to do that, we're going to do opposite operation. It's plus 7, so we're going to minus 7. And then this one here, the 3, is going to come over. It's times, so to solve this, we're going to have to divide. So that's the plan. So I'm going to work this out over here in this area right here. So I've got 3w plus 7 equals 19. I'm going to move the constant over. It's plus 7, so we're going to make that minus 7. 19 minus 7. So correct me if I'm wrong, but I believe that's 12. So I just bring this down and I rewrite it. So now I'm doing that next step. I've got to move that 3 over. Okay, so it's 3 times w, so I'm going to divide by 3. And I do that same thing on both sides. So in this case, w equals 4. And so that's how we do that. And if you look here at number 4, you're going to end up with the same thing. So that's how you do that. Okay. Now, number 5 and 6, they kind of have a different scenario here. A scenario I like to fix in a different way, so it's a little bit of a trick. I wouldn't always do this, but I personally, I'm going to zoom it back in here, personally do not like minus q or minus x or minus w. So I do a little trick here, and this is as you get to know things, you know your way around solving equations a little bit, you realize that if I take this whole term here and I want to move it over, the opposite of minus is plus, and now my q is positive. So I could do that, but it doesn't really do much because I still have this 11 over here. So then I go ahead and just do that. It's positive 11. It would become negative 11. So I do this flip-flop, and when I do that, the q becomes positive, and then I'm not messing with that whole, well, I got this negative q or losing losing the negative, because that's what a lot of people do. So what that would look like here then is I'm going to I have 11 equals 12 minus q. So I'm just flip-flop that. I'm going to bring that over, and it's going to become positive q. And then I'm just going to go ahead and do this. And I actually do write the arrows if I'm doing this. If I was writing this, if you guys could see my work page, I have the arrows written down. So equals, and I have the 12 because nothing happened to that 12. But I move that 11 over, and it becomes minus 11. And it's just kind of this quick way of dealing with that negative q, forgetting, because we always forget that there's a invisible 1 there. So it's a quick way to deal with that negative q. Bring it over, and I don't lose a step there or forget it. So now I've got 12 minus 11. Oh, that's just 1. So there's my answer. And if we go ahead and put a square around that. And if we look here, and we look at number 6, we see we've got a very similar situation here. So I'm going to leave you to that and have you do that, but that would be my approach on that. It's not always my approach, and that's a problem with teaching you guys a certain thing, because my approach changes. That's the importance of having multiple tools in your tool belt, right? It just depends on the situation, okay? So I'm going to go ahead and look at number 7 here. Now this is two-step equations. We actually did a two-step equation assignment last week. I videoed on my video from last week. We have several problems like this, and it doesn't change. So we're again recognizing, I'm going to come back here, we're recognizing that this is the constant. So I'm using the same colors as that first one, and this is the variable term. And it looks weird because the variable term is divide instead of times, but we still approach it that same way. Now the other thing that's weird about this is that all of that is on the right side of that equal sign. So you're on the right side, and over here we're on the left side. So over here we moved everything to the, on number 3 we moved everything to the right. On number 7 we're just moving everything to the left. Makes a, and might have a little bit of an issue space-wise, but it's really not that much different. So I'm going to go ahead and write my problem down. So 5 equals z, which a lot of times you have to be careful. It looks kind of like a 2. I don't know. Okay, so I'm going to move my constant first. So minus 3 becomes, oh, that's just plus 3. I'll write plus 3. So that's 8 equals z divided by negative 4. Now I have to think inverse operation or opposite operation. 5z divided by negative 4, and I want to undo the divide. I'm just simply going to times by negative 4, which is that same idea as negative 4 over 1. So we reduce. So then come over here and times by negative 4. So we get z equals, and we can't forget those sign rules, negative 32, and that is a 2. So we get z equals negative 32, and then that would be the answer here. Okay, so again, we take a look, we take that step back, and we look at 8, same type of problem. The only thing different on this one is that on this one, on the one I just did, everything was on the right side, so we moved it to the left. Okay. Over here, everything's on the left side, so we're going to move everything to the right, so everything's going to go this way. But it's going to be that same process. Okay? Opposite operation. So if this is plus 4, we're going to minus 4. So plus 4, we're going to minus 4. If we're going to divide by 3, we're going to times by 3. Okay? So that's your approach there. And go for it. So, okay, so now we're moving into a whole, it's a little bit different because, you know, just like this number 7, we had oops, sorry about that. Just like with number 7, we had like a divide right here. So we have a divide here, but we have a divide and it's dividing that variable, and it's a little bit different here. It's also dividing the constant. And so it's not just under one, it's under both. So there is a trick to this. Again, it's different tools in your tool belt. So instead of undoing the h plus 6, instead of doing the plus 6 first, we can't do that because the 6 is also divided by 5. And so we can't do that. So what we need to do is we need to get rid of this 5 first. And so this is really kind of changing the perspective. This needs to go first. Okay, and to undo a divide by 5, we're going to end up multiplying by 5 to get rid of that. Okay, and then I'll show you the rest, but I just want to show you the difference here. Here it's just one term, number 7, one term divided by negative 4. Number 9, both terms divided by 5, so the 5 has to go first. Okay, so this is what that would look like. Okay, I've got h plus 6 divided by 5 equals 2. So I'm going to multiply by 5, and we know that's over 1, so times 5. We don't have to write the over 1. It helps over here because we see, oh, look, these cancel. But on the right side there, we can just simply say, oh, that's 10 equals h plus 6. Now, some of you are going to look at that and go, I know the answer. That's fine. Awesome. So, but we're going to double check because sometimes signs can mess this up. Not on this problem, hopefully, but, and we realize, oh yeah, h equals 10 minus 6, so h equals 4, and that is our solution. So that's saying if I put 4 in right here, 4 plus 6 is 10, 10 divided by 5 is 2. And yes, that works. So that is how that works. So it's a little bit different. So how is it different? Well, we had to get rid of the divide by 5 first by multiplying. And that was just in a different order than what we did in number 7 and that we've been doing in problems like that. Okay, so that means then on number 10, same setup. Oh, look at that. So we're looking at that and we go, oh yeah, so look, yeah, it is. The negative 2 is under both of them, so we have to get rid of that negative 2 first. So we're going to times by negative 2 on both sides. Okay, so be careful of your sign rules. Be super careful of your sign rules. Some of you are missing stuff because of them, but that would be the approach that you could take. All right, so we're moving on, and now we're getting into some of those multi-step equations. And if you remember from when we did this before, there were sometimes some steps we had to do before we started crossing the river. So if you remember, we had the river on these. Okay, so some steps we had to do. We had to make it as simple as we could on each side of the river before we started crossing over. And so there's nothing we could do on those previous problems, but now we're getting into problems that do have something. So if we look at this, we can go, oh, look, this is a variable term. Oh, look, this is also a variable term. They both are the same variable. So before I start crossing the river, I'm going to actually add those like terms. Okay? And so there's some simplifying that needs to take place. And when I do that, I get 8y plus 3y equals 11y. I'm going to go ahead and make that my jumping point as I copy the problem down here, over here. So 11y equals 44. Divide by 11, divide by 11, y equals 4. And so once you combine those like terms, in this case, it became much simpler. And what you're going to notice here, as I zoom back out, is the variable term, like terms, they both have n. And so we're just simply going to simplify those by adding like terms first and then go on. Okay. Then you can cross the river. Then you can do your opposite operation. Then you can divide both sides by 11 in number 11's case. Okay. All right. I'm going to get rid of that. Okay. So 11, 12. 12 is just like 11. They're a pair, so if you know how to do 11, you can do 12. 13 and 14 are the same idea, only on two separate lines because they're longer problems. But once you know how to do 13, you can probably do 14. Okay, so we're going to go ahead again. We're going to look at this, and I've frozen, so I guess I'm not going to do that. My screen froze. So I have a variable terms. And then I have a constant term. And so that constant term is just going to hang out right now. But what I have with this variable term is I have two terms that have like terms. They're like terms because they both have a variable. And in this case, the same variable. And constants can also be like. We just don't have to happen to have any on that side. And so 12v plus 10v is 22v. And so now I'm going to come over here and I'm going to start my problem. So I've got 22v plus 14 equals 80. And there we go. Get the constant away. Plus 14 becomes minus 14. So this is like a problem if you step it back to, I think, number 3. So 80 minus 14. So 80 minus 10 is 70, minus 4 more is 66. Equals 22v. Divide each side by 22. V equals 3. And that is that. And that's all I'm going to show you right now. I will show you more, but I want you guys just to jump in there and see if you can do those, those even problems now. I know there's more down below, so I will add a video at some point with those. And that would be 15 through 22. So I will add a video with that later on. I just want you to focus on one thing. I mean, this is a lot of stuff. So, and then you could go ahead and do that. Okay? All right, I'll try to get this up here pretty quick, and then you can check it out. Thanks.